Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to create our own custom object detection model using YOLO12, which is the latest object detection model, and we are going to detect a parcel, or let's just say we are going to detect object on moving on the conveyor belt, and then we are going to use Gen AI Gemini 2.0, the latest vision model, and we are going to enhance our custom object detection with the help of Gen AI and YOLO12. So before we move to our practical, friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, as I mentioned, we have already done with YOLO12 default object detection, where we detect vehicles using YOLO12, also Gen AI vision. So in this session we are going to create our own custom object detection model with the help of YOLO12, and we are going to detect object which basically moving on the conveyor belt, and with the help of Gen AI Gemini 2.0 we are going to enhance our custom object detection. Simple. So for that I have created a new repository. I will mention the link. Simply copy paste the link inside web browser, then go to the code as we always do and download our zip format repository. It will download our zip format repository. So we successfully downloaded our repository. Just open download folder. This is what our repository. Right click, then click on extract all. It will extract our folder. This is what our folder. Go inside folder, and then we have our all the files. Simple. So we have here our video file. So let me first run the video file, then you will get the idea what basically we want to detect. So co.mp4. So friends, as I mentioned, this is what our video file, and we have here our object. So this is what our object, as you can see, this is the object. So this box is basically moving on the conveyor belt, and our goal is to detect the object. Means our goal is to detect this box which is moving on conveyor belt. So for that we will use YOLO12, and we will create our own custom object detection model. And then friends, because we have now our Gen AI vision, so we can enhance our object detection using Gen AI. So our goal is to not only detect the object, also enhance the observation. So for that, let's just watch this video. As you can see, this is the box. So we can clearly see this box is open. As you can see, this box is open, and if I just run the video file again, so as you can see now, for next box, this box is completely packed. There is no open. Simple. This is the flip is not open, or we can say the flap is not open. Here it is. As you can see, completely sealed. This box is perfect, and this box also the perfect. Simple. So the first box, if you go back, first box, as you can see, the first box is open, and we can see what we have inside this box. So it means with the help of object detection we can detect the object. We can create our own custom object detection model using YOLO12. But if we want to enhance, or let's just say if we want to check that the box is perfectly okay, so for that we will use Gen AI. So we detect the object. So when we detect the object, we have rectangle coordinate. So we will crop that rectangle coordinate, and we will send this image to Gen AI, and Gen AI will observe the image, and it will say this box is open. Means this box flap is open, so it is not perfect, we can say. And for next box, as you can see, now there is perfect box. We can see this box is not open. Same way for the next box. Simple. So for that we will use a Gen AI vision model, and we will first create our own custom object detection model which detect the box. Then with the help of our rectangle coordinates, we will send The rectangle coordinates image means we will crop the rectangle coordinate and then we will send that image to Gen AI, and Gen AI will be observed and it will create the report, and we will save the report inside the text file. Also, we will not only create the report, if we detect any fault, it will run the audio file, it will run the alert. So for that I have mentioned inside repository, I have mentioned the alert.mp3. This is the alert audio mp3 file which play with the help of Pygame. Only we detect any fault. If we detect any fault, with the help of Pygame we will run this alert audio. Simple. So this is the project. First we will create our own custom object detection model using YOLO12. We will use RoboFlow. Then we have now our model, so we can detect the object. So if we detect the object, it means we have the rectangle coordinates, which is x1, y1, x2 and y2. So we will crop the image. Simple. We will crop the image and we will send the image to Gen AI. Gen AI will be observed if there is any fault. If the fault is there, it will play the audio file using Pygame. Simple. So this is what our whole project. Also friends, we will not detect these boxes all over the conveyor belt. We will detect only in particular area. For that we will use the method which is the line method. We will draw the line on the frame and detected object center box. If it is touch our line, then only we will draw the rectangle and then we will crop the image, we will send the image to Gen AI. Simple. So this is what our whole concept. So now first step, we want to create our own custom object detection model. So for that I will simply open RoboFlow. So you have to create the account using your Gmail ID and it will create your account. So I have already created. Just click on new project, then select YOLO12, and here I will not mention the box class, I will mention the object, because the object is the class, and then Gen AI will be recognize or observe what is basically the object, if it is a box or if anything. So I will create the class which is the object. So object is basically annotation group object, and then we will go with object detection. So select object detection, create private project, it will create our project, and the file we will directly use our video file. So select file, go to the repository. So this is what our repository, YOLO12 Gen AI custom object detection, again same folder, and this is what our video file co.mp4. Select it, click on open, it will upload our video file, and then we need the images from the video file. So here we want to select how many images we need. So I will just go with the 32 images. You have to simply move this as per your requirement. You can select the images. Simple. So for this tutorial we will go with 32 images. 32 images is enough. So just move, and when you will see here 32 images, just stop, choose frame rate. Now it will generate the 32 images using our video file. As you can see, it's uploading file. So friends, this is what our images from our video file. Now here we want to click on start manual labeling. Click on start manual labeling, then click on assign to myself, and then you will see this kind of page. Now click on start annotating. We will start our annotating using the box. So here we want to select the bounding box tool, and then we will simply draw the bounding box on our object. Simple. So let's just draw it like this way. That's it. We already mentioned the class, so object is basically annotation group, or let's just say the class. Click on save, go for next image, draw the rectangle box like this way, click on save. Then we have this box, as you can see, we can see the box, so let's just draw over here also a small bounding box. Click on save, go for next image. This is the box, as you can see. Here also we will draw the rectangle box on the box. Click on save. Then this is the new box. So here also we will draw the bounding box. Click on save, go for next image. Again here we can see there is a box, so let's just draw the rectangle. Then click on save, go for next, draw the rectangle box, click on save, and for this also click on save, then go for next box, draw the rectangle box, save, go for next image. Here we can see there is a box, so just draw it, click on save, go for next image. Again we have here new image, so we want to draw the rectangle on our object, click on save. So this is how I will draw the rectangle on each box. Simple. So let me draw it. So friends, I have done with drawing the bounding box on each image. As you can see, this is what our last image, 32 out of 32. Simple. So we have done with annotations process. Now just click on here where you will see your project name, which is the YOLO12 in my case. So just select it and you will see we have completed the process. We have unannotated 0 and we have annotated 32. Just click on add 32 images to dataset. Click on add images and it will add our images into dataset. Simple. Now just go here in versions, train versions, select it, and then we want to split our data. So train test split, click on edit, and then here we want to click on rebalance and just rebalance the images. So right now valid is 0 and test is 0, so we will go with like this way, valid 4 and let's just say test 2, or valid 3 and test also 3. Simple. So 27 train images, valid 2, test 3. This is basically for small model. In real scenario you need more images. Simple. So let's just save it, then click on continue, then click on continue, then again click on continue, and then click on create. It will create our data set. Now it will create our data set. Now here we want to simply select download data set and we will go with the latest format, which is the YOLO12. So YOLO12, as you can see, select it and then we will download our code. So first we want to open our Google Colab. So let me open Google Colab. So friends, I have opened Google Colab. Just click on upload, click on browse and go to the repository. This is what our repository, again same folder, and then I have mentioned the Google Colab file. As you can see, YOLO12 object detection custom dataset. Just click on it, click on open. It will upload our file on our Colab machine. So friends, we uploaded our Colab file. Now go to the runtime, then change runtime type, select T4 GPU, click on save and click on connect. So we successfully connected. Now we will run our cell one by one. So let's just click on first cell, it will run our first cell. Then we will install Ultralytics. So let's just run our second cell. So friends, we successfully run our second cell where we install Ultralytics. Now we will import our Ultralytics. So next cell, click on it. Now we will cross check if our Ultralytics perfectly installed or not. For that we will use YOLO12 s.pt model and we will run that model on the doc.jpeg image from RoboFlow. Just click on run. So we successfully run our YOLO12.s.pt model and this is what our result, 1 person, 1 car, 1 doc. It means we successfully install Ultralytics and we have our YOLO12 model. Now we want to call our code from RoboFlow. So let's just open RoboFlow. I have selected the YOLO12, show download code, select it, click on continue and it will generate the code. So this is what our code. Just copy it from copy it and open Colab, and this from to YOLO11, remove it because this is the old code, and now press Ctrl+V. It will paste our new code. As you can see, now we have YOLO12. Let's play the cell. Done. As you can see, we successfully run our cell. Now click on this small folder icon. You will see we have now dataset folder because we created dataset folder, and inside the dataset folder we will basically download our folder from RoboFlow. So dataset, as you can see, YOLO12. This is what our project, and inside that we have test, train, valid, and data.yml. Just double click on data.yml, and here you will see the folder path, train, then the valid, and then the test. So we want to change this path with this original one folders. So train folder, just go to the train, click on this 3 dot, copy path and remove the old path from data.yml and press Ctrl+V. Same way for val. So valid, 3 dot, copy path and then remove the val, paste it. Then test, same way, test, 3 dot, copy path and remove the test old path and paste it the new path. And then we have object, which is our class. So we done with this folder path. Now we want to save our data.yml file. Just press Ctrl+S. It will save our data.yml file. Simple. Now close it. And then here, this is what our main code for training. So here we want to mention the data.yml file path. So data is equal to our data.yml file path. So we want to mention the new path. So data.yml, again click on 3 dot, copy path, remove the old path, Ctrl Z and remove the old path, remove it and Ctrl+V. So we successfully paste our new data.yml file path. Data is equal to, this is what our file path, data.yml. Done. So now let's just run our cell. It will start our training. So friends, as you can see, our training is started, 100 epochs, so 1 completed, so it will take some time. Meanwhile, I will pause video. So friends, we created our model. We successfully done with our training process. So our model is basically saved inside runs, detect and train. So this is what our runs, then we have detect, then we have here train folder, then we have weights, and inside that we have our base.pt model. So 3 dot, download, it will download our model. So we downloaded our model, as you can see, base.pt. Minimize all these things, then file manager, downloads, base.pt, right click, cut and move the model inside our main repository or main folder. Done. So we have our model ready. Now we will open our main.py with the help of Tony Python IDE. So first we will go with the packages. So go to the tools, manage packages, and we will search for opencv-python. Hit enter. First package, click on install button, then it will install opencv-python. Then we need ultralytics package. First package, click on install button, or if you already install, click on upgrade, then only you can use YOLO12. So click on install, then upgrade the ultralytics package. Then we need a CVZone package, CVZone, hit enter. First package, click on install button, done, it will install CVZone. Then we want to run our audio file, so for that we need a pygame. So pygame, first package, click on install button, done, it will install Pygame. Then for AI agent we need LangChain, so LangChain first package, click on install button, done, it will install LangChain. Then we need like LangChain-core first package, click on install button, done, it will install LangChain-core. Then we need LangChain Google Gen AI because we want to use a Gen AI which is a Gemini 2.0 vision. So LangChain Google Gen AI, hit enter. First package, as you can see, LangChain-Google Gen AI, click on install button, done, it will install our last package which is LangChain Google Gen AI, done. This is how we want to install OpenCV-Python, Ultralytics. Also Ultralytics upgrade the package for YOLO12, CVZone, Pygame. We want to run the audio file, so Pygame, and then the LangChain, LangChain-core and LangChain-Google Gen AI. Simple. So we have done with packages installation. Now we need our API key, so we will open our API key, Google Gemini API key website. So friends, I have opened Google Gemini API key website, click on get API key, and I have already created one for last session, so I will delete that one. Create API key, select any project, click on create API key, it will generate our API key. This is what API key, copy it, minimize all these things, and just created any text file on your desktop, and inside that text file save our key, paste it, file, save, done. Now we will here close and close the web browser, done. Now we want to copy paste our key inside our code. So let's just copy paste here, Google API key, Ctrl+V, done, save it. Now as I mentioned, the full code is what? Full code is basically, as I mentioned, we will first detect the object because now we have our model. So we have our model which is the base.pt model. As you can see, I have already mentioned it, base.pt. So with the help of YOLO12 base.pt model, our own custom object detection model, we will detect the box. So when we have our box, we have of course the rectangle, the x1, y1, x2 and y2. As you can see, the x1, y1, x2 and y2. So we will crop the image using x1, so y1 colon y2, x1 colon x2. This is how we crop the image. We will send the image to Gen AI, and we will not track the image, means we will assign the track ID because we have Ultralytics. So with the help of Ultralytics, we have track IDs. As you can see, this is the basic method for track the ID, or track basically the assign the unique ID for each object with the help of Ultralytics solution. So we have track IDs, so we will assign the unique ID for each object. So now if we have the unique ID, it means we can simply say please don't track same ID again and again, or let's just say if only if the line, because we have the line, and when the detected object center point, here it is, as you can see, the cx is the basically center point of detected object. So x1 plus x2 divided by 2, we will get the center point. So this center point, if it is touch our line, so our line coordinate is basically this. Let me show you here. This is what our line, as you can see, civ2.line 4162. This is what our start xy coordinate. This is what our end xy coordinate. Let me start the code first, then you will get the idea. So I will mention here 0, so it will freeze the frame. Let's just save the code, let's run the code. So when we start our code, we will get the real idea. So as you can see friends, as I mentioned, this is what our line. With the help of civ2.mouse event move function, as you can see, we have basically the frame xy coordinates. Frame in the sense we have mouse cursor coordinates. So if I want to start the line from here, just move the cursor over here and you will get the coordinates here. Let me show you here, 4171. So this is how I have mentioned the coordinate. So this is what my start point for the line, and this is what my end point xy coordinates for the line. This is how we draw the line, civ2.line 4162 start xy point, and this is end xy point. Simple. So now I want to draw the line this way, this way. Simple. So for that, what I will do, I will mention the x coordinate, which is the x. This is the start point x, and this is the end point x. So I will mention this x both as the same. So 416 x for start, 416 x for end line point. Simple. So 416 416, and this 416 I will mention my cx1. So here I have mentioned the cx1. I will show you here. Here it is, as you can see, cx1. The x position of the vertical line. This is what our vertical line. X position for vertical line is basically the 416. So what is 416? 416 is my line start point x coordinate, line end point x coordinate. So this point, when the object center point touch the line, then only we will detect the object. So this is what my condition, as you can see, self.cx1. Self.cx1 is why? Because we created the class. So we mention this as self.cx1. Simple as, and this is the offset. So now, as you can see, the object is there, but there is no rectangle, there is no track ID, because we created the condition. When this object center point touch the line, then only I want to detect the object. So I will simply skip the frame one by one. As you can see, I will skipping the frame one by one, pressing my space button from the keyboard. When this object center point touch the line, as you can see, it's now touched the line, friends, and as you can see, there is a alert message, there is a alert sign. Let me stop the code. You listen, there is a alert message, or there is a alert sound. Why? Because there is a fault in package. The package flip is open. Simple. So that's why we created the condition. If there is any defect in the package, or here it is, as you can see, I have mentioned the AI prompt, Gen AI prompt for our agent. So how basically agent work? So this is what my text, or this is what my prompt. This is how I want to act my agent for this particular scenario. Box front open, yes or no. Damage condition, yes or no. So this is the table. So package type box, because the package type is box, and then the box front flap open, yes or no. If it is open, then it will run the audio file and the damage condition. You already hear that there is a alert sound. So the alert sound condition is basically, let me show you here. Here it is, as you can see. This is what our, this is where we saving the data inside our file. Here it is, as you can see, the file.write. Simple. So we are writing our data inside the file. So inside the file, when we have flip open, we will trigger the alert. So if box.open lower, if the yes means the box.open, this box.open variable, if the box.open is equal to yes, means the box is open, then we will create the alert. Alert trigger is equal to true. And then if alert trigger means now here we detected the box is open. So of course now we want to alert the trigger. So trigger alert is true, and then if the trigger alert is there, then we will play the music. So music play is basically we created here function, as you can see, def play alert self. This is how we will use the pygame.mixermusic.load self alert sound. So this self alert sound is basically our music file. As you can see, the alert.mp3, this is what our music file. Simple. So this is how we will generate the alert when we detect the object means here we have the box. So when we detect the box flip or any damage is there, it will create the trigger. And what is trigger? Trigger is basically our alert.mp3 file which you already hear. Simple. So now we will run our while loop. Let me show you here one more thing. We have crop packages image. We detect only one package. So this is what our image, as you can see. This image we are sending to Gen AI. So it's saving the images inside crop folder, and we have the text file, and inside that text file, as you can see, the response from Gen AI. Package type, so first is basically the track ID, so track ID 1, package type box, and box front flap open, yes or no. As you can see, it says the yes, means the Gen AI observe the image and it's creating the response that this box front flap is open. It says yes, but there is no damage, basically only the flap is open, yes. Simple. So this is how all the way code will work. Now we will start our while loop. Let me first delete the folder where we are saving our images and the file. Close it, just click on yes, it will delete, and then I will start the, I have mentioned the 1, so it will start our while loop. Save the code and run the code. So it's detecting. You can see there is an alert, and then we have other boxes. Remember one thing, friends, because we created only 31 images, because this is just a small video, in real scenario you need to create a more perfect model using more images. Simple. So now we have our file where we have our report. So track ID 31 box, as you can see the box front flap open, yes. Simple. And then we have package box, here it is, as you can see it says no, and then again the package is basically yes, and the package type is also the box, as you can see. Simple. What I will do, friends, because there is some fault detection, that's why it's creating because it's detecting the false object, so we have a false response. I have already created the perfect model, so I will mention that model inside repository, no problem. Also, I have already shown you how you can create your model, because I have mentioned the small images, only 31 images, that's why there is some fault detection, no problem. But I have created the model already, and we will use that model over here. So I have the model inside my old file here, and I have the model, this one, best.pt, and I will mention inside our repository. I will mention this model inside of the repository, which I have already mentioned for the link for this project. So I will create this as a 1.pt and I will paste this model. Simple. This model is perfect because I have already tested, and with the help of this model there is no fault detection. So now again I will delete the crop packages and the text file, and then we will start our code again. So as you can see, for this model there is no fault detection. Simple. The alert sound is there, and when the file is over, all close, and then we have our report. As you can see, this is what our report txt file, and as I mentioned, friends, the model which I have created already is perfect, is perfectly working. There is no false detection. So we have only 3 boxes, so we have only 3 track ID, 1, 2 and 3 track IDs. Means with this model, this custom object detection model, for this video it's perfect. So I will mention the model, but I have shown you the method how you can create your own model. Remember one thing, friends, you need more images, for perfect model. Simple. So main thing is what, let's just check the report. So track id 1 package is box, and the box front flap is open. Yes, it says the yes, because the the track id 1 box flap is open. Yes. And the second track id box, the second box, there is no flap open, there is no damage. And the third box also, there is no flap open, there is no damage. Simple, friends. So this is how you can create your own custom object detection model using YOLO12. Also you can use Gen AI for better observation. You will get this kind of result. Simple. So as I mentioned, I will mention the model also. I have mentioned the full code, the video file, and the alert sound also. I hope you will learn something from this video. We will meet our next video. Till then, thank you, take care, and bye bye.